Hey guys, welcome back to Consistent Code. So today's problem of the day, find a state position. It is a very famous problem. Basically what this problem says, suppose you're given a circle, this is your circle having, let's say, four elements. Now in the circle, the first person, I'm saying this there are four persons. In this case, we can consider the input as n equals to 4 and k is equals to 2. N equals to 4 means there are four people. So I'm numbering them as 0, 1, 2, and 3. And k equals to 2 means that in every turn, the kth person from this person who is holding the gun dies. So the 0th person will shoot the kth person, that is 2. So this person dies. Now the gun is handed over to person 3. Now this third person again shoots the kth person, that is uh, often in the circle of second person will be 0 and then 1. So 1 is shooted via 3. Now again a gun will be handed over to 3 and the second person in the circle of two people will be 3 himself. So 3 shoots himself or herself and we are left with 0. And hence the position of this person 0 will be 1. So answer for this case should be 1 for n equals to 4 and 2. Now, I hope you have got the basic idea what we need to do in this problem. So how to approach this problem? To solve this problem, you can consider using recursion. Now, why we are using recursion? Because suppose there was a circle of four people, then initially what is happening, if you will observe that the first person first kills one person and then we are left with a circle of three. So can I say it like it is like a recursive function, initially having the input as n and k, and this input is getting reduced to one person less, that is f of n minus 1, right? So I hope you've got the idea how we can um, know solve this using recursion, right? So basically, this is the idea which we can follow. And what will be the base condition? This becomes our induction in the recursion. Now, what can be the base condition in our recursion? So the base condition will definitely be if there is only one person in our uh, circle. If there is only one person, then he will, whatever may be the value of k, he will always kill himself. So we, in this case, we can simply return uh, the position as 0 or the position should be first. So what we can do in this circle, since we are considering indexes of 0-based indexing and but we will need to return the position in 1-based indexing. So in the end, we can just add 1 to whatever answer we get in the 0-based index, right? So that's it. That's all that we need to do in this questions. And yes, there is one more thing that basically what will be f of n and k. That's not like it will be f of n minus 1 k. There needs to be this needs to be modified. Now let's see in our code how we can modify this thing. So let's go to the code and just code it. So obviously, since we are given a one-based indexing, what we can do, we can return this thing in, let's say our recursive function is f, and so f of n comma k, this will give us answer in 0-based indexing, and we need to add 1 because we need answer in a 1-based index. Now all we need to do is create this function which gives us answer in 0-based indexing. So we can just create a function into f which takes two arguments as n and k, and now we need first specify the base condition, which as we discussed before will be that if number of people is only one in circle, then that should always return 0 because the 0th person, there's only one person, then only that person is going to die. And if there is one person, then in zero-based indexing, we should return a 0. And this becomes our base condition. Other than this, what we need to return, now we can just put something over here. If it is a circle of 4, then it is dependent on a circle of 3. Because if this guy kills, the first person kills one person, then a circle of 3 is left. So basically, whatever answer which we get from a circle of 3, we need to add k position in it, and that becomes our final answer. For example, if we are killing this guy, then we are moving k distance from the next person. So then we get when at 3, and then we are moving k distance from it to kill the next person. Basically, what that means, if we are having an input of 4, then this basically depends on, the input of n minus 1. Now, how? Suppose it is a input of 4, then we can see if we are having an input of 0, 1, and 2, whatever input or the answer will be for the cycle consisting of 3 members. Suppose the answer is 2 for the cycle. Then the answer for the 4th cycle will obviously be, if we add k to this position, whatever position we get from this case, suppose we are getting position 2 as the output from this case. So we just need to add k in it, right? And this position becomes our answer. And yes, we need to take a mod with the size of the, and because 2 plus 2 will be 4, and 4 mod 4 will give us the index 0. So can I say that this becomes f of n minus 1 comma k, and we need to add k in this and take the modulo of this complete expression with the number of people in our current circle. So basically, this becomes a value of our f of n. If we are having n people in a circle of, and we need to move k distance. So what we are doing, since it is dependent on the circle having a one member less than that, so we are considering the value of that circle of circle consisting of n minus 1 members, and whatever will be the answer for that, we need to jump k steps from that and kill the next person. And hence, we just need to take the modulo with n so that it remains in the indexing of our n people in the circle. I know it's a bit complex, but if you didn't get it, you can just rewind the video again and watch this again. So what we are returning, we can simply return f of n minus 1 comma k, that is, since it is depending on the input of n minus 1 circles. And what will be the actual answer for the circle with having n members? If we add k position in the answer which we got from the circle having n minus 1 people, and we obviously need to take a mod n, right? Now let's see by compiling and running our code if this is working properly. This is working properly, but this test case. Now let's submit this and check if we are able to get past all the test cases. And yeah, it passed all the test cases. And I hope you understood the problem. And if you did not, I know that it is a bit complex, and I request you to please rewatch this video and get the intuition. Now, I hope you liked the explanation, and if you did so, make sure you hit the like button and subscribe to the channel, and I will see you tomorrow with the next problem of the day.